In the name of Almighty Allah, the most gracious, the most merciful. As Muhammad, peace be upon him, narrated, if anyone travels on a road in search of knowledge, Almighty Allah will cause him to travel on one of the roads of paradise. Hello everyone, this is Dr. Tariq Masood. Thank you very much for watching my videos and your wonderful support to make the channel a grand success. We are a partner, a family. Please subscribe and share our channel if you haven't done so far. We as a team can work together to convert our challenges into opportunities and opportunities into success stories. These success stories can be monetized into value addition in the world by large. Okay, today I'm going to discuss my lecture number 23, oil and gas productions, exploration, productions, upstream, midstream, refining, petrochemical differentiated performance, enabling profit optimization process, lecture number 23. Before my lecture, I used to read a Quranic verse. Qala Rabbi shrah li sadri wa yassir li amri wahlul uqdatam min lisani yafqahu qawli Allahumma Rabbi zidni ilma. O my Lord, open my chest and ease my task for me, and loose a knot from my tongue that they may understand my saying. Allahumma Rabbi zidni ilma. O Allah, advance me in my knowledge and true understanding. Please send me your feedback. I have provided my email address and WhatsApp number at last slide of my presentation. Oil and gas production. Introduction, we have discussed facilities, process, reservoir and wellhead, upstream facilities, midstream facilities, refining facilities, petrochemicals, utility system, unconventional and conventional resources and environment effects. What is the ultimate goal? Shaping the clean and sustainable global energy delivery. So plan to deliver a more than a 300 lecture next couple of years. Okay, oil and gas production, downstream facilities, lecture number 23, refining, we are still discussing. Okay, so key takeaway points from lecture number 23, the refining process, advanced process that is atmospheric vacuum distillation and hydrotreating, etc. Okay, advanced refining process, the refinery makeup differs from an upstream plants in that the overall site is divided up in the process types or units. The refining plants type process are generally licensed and a license is required to build and operate one of these. Each license will be same but scaled to meet the process capacity in tons or barrel whatsoever. So we will discuss in detail. So today we will give a non-exhaustive description about the advanced process operations. Okay, so the actual modern refinery, it shows the extent of treatment that makes a place a different initial fractional distillation to improve a fuel yield and functional properties, and an explanation of why modern gasoline at the pump contains a less than 20% raw gasoline straight from the column. So we may discuss additional process may also be, we will include later on. So the crude pre-treatment to be the source a lower quality crude with less processing at the production site. Okay, advanced refinery process. If you can see the flow diagram of the actual modern refinery, it shows the extent of treatment that take place after initial fraction distillation to improve a fuel yield and functional properties, and an explanation of why modern gasoline at the pump can less than 20% raw gasoline straight from the column. Additional process may also be included. In my next slide, we will discuss for crude pre-treatment to be the source a lower quality crude with less processing at the production sites. Okay, If you can see here, okay, if you can see here, the first one is my vacuum, my atmospheric distillations. Over here is my vacuum distillation, and over here is my different process units. Okay, so this light blue color demonstrates a sulfur recovery, LPG here. Here this is a jet fuel, and over here this is a diesel. So over here are the fuel oil and the other products. We have also demonstrated here the gasolines blended upward. Okay, these different process we will explain in my next slide. So detailed discussions on atmospheric distillations, vacuum distillation, hydrotreater, Marx unit we will discuss on a later stage. Okay, advanced refinery process. Most of these reactions takes place at elevated temperature and pressures over a catalyst such as platinum or uraniums or sometimes iron, and need a precise control for optimal throughput. A few process flow diagrams have been also included, as we discussed earlier, to give an indication of the complexity of these processes compared to the relative simplicity of many upstream production facilities. Okay, first, what is atmospheric distillations? Is the frictional distillations unit already we have discussed earlier. In actual design, it is combined with vacuum distillation. Raw crude cannot be heated to more than 370 to 380 degrees Celsius. It is often called the crude oil distillation unit, or CDU. Okay, vacuum distillations. Vacuum distillation unit, a VDSU, further distills the black oil into the fuel and residual bitumen and coke to avoid overheating the crude and to extract additional valuable product that could be upgraded. Okay, naphtha hydrotreater. Various sulfur compounds are present in the hydrocarbons mixtures, and if burnt with the other carbons will cause sulfuric emissions. The hydrotreater uses hydrogen to remove some of these compounds. As an example, we can see the hydrodesulfurization HDS reaction where the ethanol can be expressed in my over here with the chemical reactions. If we can see here, this is my C2H5SH reacted with hydrogen. So what it will produce? C2H6 and H2S, hydrogen sulfide. Okay, so the first is, this is my ethanol here. This is my ethanol, and reacted with the hydrogen, and then it will produce ethane and hydrogen sulfide, C2H6 ethane plus H2S hydrogen sulfide. Okay, catalytic reformer unit is used to convert the naphtha molecules C5 to C12 into higher octane reformer product. These are mixed with raw gasoline to achieve a higher octane product. The process creates more aromatic ring-formed hydrocarbons by dehydrocyclizations, or more complex hydrocarbons with double bonds or side groups by hydrogenations. These processes release hydrogen, which is recovered and can be reused in hydrotreater or hydrocracker. Okay, fluid catalytic cracker (FCC) unit upgrade heavier friction into lighter, more valuable products. Long chain molecules, high carbon numbers are split into shorter molecules to achieve more of the high value of fuel components. A typical design uses a reactor and regenerator, a fine porous catalyst with zeolite, silicate, and alumina is fluidizing in the hydrocarbons vapors, where reaction takes place at 535 degrees C and 0.175 MPa. The catalytic reactions take place within a few seconds, after which the reformate and catalyst is separated in a cyclone. The spent catalyst then goes back to the regenerator that heats it up to 715 degrees Celsius at a 0.241 MPa megapascals and release of flue gases. Okay, the catalyst powder can then be reused. The reformates go to distillation column for separation in the fractions. Okay, next is hydrocracker unit. The hydrocracker unit perform essentially the same function as the FCC when a more saturated hydrocarbons are desired in the product. This means alkanes carbon chains with single bonds, not double bonds or cyclic rings like aromatics or more complex molecules. For this, additional hydrogen is needed. The reaction takes place with hydrogen under pressure over a catalyst. The relatively market needs for the diesel, kerosene, and gasoline will influence the choice of FCC versus hydrocracker in different countries, but in particular in the US, with higher relative volume of gasoline, a more FCC capacity is needed. While in Europe and Asia, with the higher diesel consumptions, a more hydrocracker is used. Okay. The last is the waste breaking units. Upgrade heavy residual oil by thermal cracking them into the lower viscosity product that can be blended into lighter, a more valuable product. Waste breaking is characterized by its thermal severity. Okay, ranging up from mild cracking at 425 degrees Celsius to severe cracking at 500 degrees Celsius, depending on the residual oil. As much as 15 to 25% lighter fractions like diesel, kerosene, and gasoline would be obtained. Okay, so the residue is tar and coke. Okay. Advanced refinement process. First, we'll explain Marx unit. Marx unit treats LPG kerosene jet fuel by oxidizing mercaptans to organic disulfides. The purpose is to reduce strong odors caused by the thall's presence. Number two, coking units. Delayed coking, fluid coking, and flexi cokers like the web breakings use a thermal cracking of very heavy residual oil into gasoline and a diesel fuel. The residual is green coke and is further processed to fuel coke, or if too low, in a sulfur and containments to anode coke for the metallurgical industries. Number three is alkylinations. Unit produce high octane components for the gasoline blended. The main use is convert isobutane C4H10s but arranged differently than N-butane to alkylates. Mainly isooctanes or isoheptanes by adding an alkyl group such as propane or butane over a strong acid catalyst such as sulfuric or hydrofluoric acid. Okay, now we'll discuss dimerizations is similar to alkylinations but uses a dimer group instead of an alkyl group. For example, butanes can be dimerized into isooctanes which may be hydrogenated to form isooctane. Okay, next is the isomerizations. Units convert linear molecules to higher octane branched molecules by rearranging the same atoms arranged in the different way. For example, C4H10 and butane has the carbon atoms in a chain while isobutane has central carbons with one hydrogen and three CH3 groups attached. The isobutane can then be fed to the alkylinations unit. Steam reforming. Okay, steam reforming produces hydrogen for hydrotreater or hydrocracker. Typically is a steam methane reformers SMR, where steam reacts with methanes at 425 degrees Celsius with the nickel catalyst to produce synthesis gas, which is source for many different reactions. Okay, CH4 plus H2O, so it will produce a CO plus 3H2 hydrogen. So if more hydrogen is needed, so then CO, carbon monoxide, react with H2 water and produce CO carbon dioxide plus H2. Just we will also show its chemical reaction over here. Amine gas are treated cross units and tail gas treatment convert hydrogen sulfide from hydrodesulfurization into elemental sulfur, which is a valuable trade product. Okay, I'll give you first a CH4 here. CH4 react with steam H2O, and it will produce carbon dioxide and plus a 3H2O, H2 hydrogen. Okay, so if we want further, then again, so then a CO, carbon monoxide, a plus again steam H2O, and it will produce carbon dioxide, CO2, and plus H2 hydrogen. Okay, thank you very much. It was my last slide. So we will conclude, and then we will give next plan what we're going to discuss in my next presentation. Conclusion. Today we have discussed advanced refinery process, atmospheric distillations, vacuum, distillations, naphtha hydrotreater, catalytic reformer, distill hydrotreaters, hydrocrackers. So we next topic, oil and gas production. We are still discussing refinery. So after finishing, we will discuss in detail, more detail about each unit. References: a few references: Petrochemicals, Oil and Gas Development, World Energy Outlook, U.S. Geological, U.S. Department of Energy, Shell Budgets, Oilfield Glossary, International Energy Agency, Wikipedia, Oklahoma, State Oil, Fact Sheets, Norsex, The Story of Oil and Pennsylvania, Air, Liquid Gas Encyclopedia, Natural Gas from the Wellhead to Burner Tip. So together everyone achieve more. Please do not hesitate. Send me your feedback, comments at t.masood.dear@both.edu, and also I have provided my WhatsApp number. You can also send me through WhatsApp. Please stay at home, stay safe, inspired, and blessed. Thank you very much for your patience.